So I thought about this issue in a different order. And actually, when we learned about this forthcoming conference, we created a thinking team at the Faculty of Science. And we thought about it in threats, benefits, and possible solutions. And it is true that the 21st century confronts us with several major challenges. We have a global population that becomes urban. We have life expectancy that increases, but yet we need solutions to ensure the life quality for that time. We have a crisis in resources worldwide, and all that brought to my mind the quotation of the Stanford economist Paul Romer, who said, a crisis is a terrible thing to waste. So we have a situation where we hope science can offer a solution that never could have been offered. And we tried at the faculty to find the points that are the focal points of these crises and where science can offer solutions. So in saying that, I do not represent only the biologists, but also the better scientists of the exact sciences in our faculty. So if one thinks about the Earth's dwindling resources, the environment that collapses around us, we thought about the essential need to ignite renewable energy, which was mentioned already. We wanted to be able to predict climate changes. We did mention that understanding earthquakes is a must, and that was before the news of last week. So apparently our members in the Institute of Earth Sciences know what they're talking about, and certainly water research was mentioned. We further pointed at communication gaps in a global village as a problem. The world is becoming smaller and smaller, and yet communication problems become deeper, at least between some sectors of humankind, which is a threat to all of us. We talked about the need to harness quantum mechanics to improve communication gaps in the level of computer science. We thought about the principle of size, and size does matter in nanotechnology. The achievements that we already see in nanoscience and nanotechnology bring us back to the need to reassess the properties of materials. And for a biologist, that would mean that you need to recheck the quality of a drug that we all knew works in a certain way for many years, but now it's delivered in a different size particle, and that changes the features of that drug. We talk about the need to revolutionize bioengineering. And in that aspect, our Boris Rubinsky, a professor at our faculty, who just joined us after spending many years at Berkeley, has developed very recently, it was on the news last week, new means to use cellular phones, which links to the previous speaker, as a medicine assessment, or assessing the medical conditions of a patient, even if that patient sits in an area without doctors, without any means to take care of him. At least they could know what went wrong. And finally, we talked about the need to rationalize decisions in a world of irrational decisions. And again, expanding the implications of game theory comes to mind. The achievements in game theory took place 30 or 40 years ago, and yet Robert Aumann of our faculty, who is a professor of mathematics, won the Nobel Prize in Economy only 2 years ago. Perhaps game theory today could be expanded to have implications in many other fields of science. We talked about genomics, and that brings me back to what I know what I'm talking about. So we are in the age of the past genomic age. Genome research has gone through the very first phase of finding the sequence of our genome. That's not enough. We know what is there, but how do genes talk to each other? We know to identify many diseases that are determined by one gene going wrong, but we don't know to assess those diseases which are the prevalent ones. That the emergence of which depends on many different genes going wrong just a little bit. And it's the combination that we need to study now. And finally, my really close to my heart field, the final frontier, brain research. We could map the human genome because it's simple. It's unidimensional. True, there were very many bits and pieces to determine, but it was done. The brain is much more complicated because it's three-dimensional. We don't know yet how brain cells talk to each other and what does that mean. And I can only agree with Mr. Ponicki by saying that the links with biology are crucial. The life sciences can provide many solutions only if the barriers between our field and quantum mechanics and information science and game theory are broken. And there is, I think, the biggest communication gap that I can think of, and I can only hope that science can provide the solution to that. Thank you.